This presentation is delivered by the Stanford Center for Professional Development.
All right, so time for our next topic. And our next topic is really a little bit of a revisiting of an old topic, kind of an old friend of ours, and then we're going to push it a little bit further. So remember our old friend, the interface. I always love it when like math books say like recall, and then they have some concept, and I look at that and I'm like, oh, recall the interface. Like, oh, what good times the interface and I had. Like we were holding hands and running through the garden, the interface and I recall our happy times together. So now's the time for you to recall the interface. What was an interface, right? Last time when we talked about interfaces, we talked about something really generic, which was basically, it was a set of methods. And this was a set of methods that we sort of designate that some set of classes actually shares. So it's a common set of functionality, among a certain set of classes. And we talked a little bit about how, yeah, if you had some notions of inheritance or a class extending another class, you get sort of that same idea. But the real generality of interfaces was that you could have certain things that weren't related to each other in an object hierarchy or a class hierarchy, that you still wanted to have some common methodology. And you sort of saw this all before. So in the days of yore, when we talked about G objects, remember? Those little fun graphical objects like the G label and the G rect and all that happy stuff. And we said there were a bunch of interfaces there. Like, for example, there was an interface called G fillable. And the G fillable interface had certain methods associated with it, like you could set something to be filled or you could check to see if it was filled. And we said some of the objects actually implemented this interface. So for example, G rect and G oval and a couple others actually implement this G fillable interface. And there were other things like G label where it didn't make sense to have a filled or an unfilled label. So G label didn't implement this interface. Okay, and it was just kind of a set of functionality. And we're going to kind of return to this idea of interfaces to talk about some of the things that we've actually done so far, like array lists and some new concepts you're going to learn and how it relates to our notion of interfaces. But the more general thing to take away from interfaces is in terms of thinking about how they're actually implemented for their syntax. Sometimes what you'll see in the actual code when you see that a particular class implements the methods that are considered part of some interface, the way we write that is we say public class, and then we have the class name just like we usually do. So I'll write class name here, and I'll underline it to indicate that this is just a placeholder for the actual name of the class as opposed to writing class name. And then what we would write is implements. This would all generally be on the same line, much in the same way when you've seen before, like your class my program extends console program or extends graphics program. Here we have a notion of implements, which is an actual word in Java, and then the name of the interface that it implements. So this would over here would be the interface name. So you can imagine somewhere in the definition of the grect class, there is a grect class that implements gfillable. And gfillable is defined to be some interface somewhere which just specifies a set of methods. And any class that implements that interface needs to provide its own version of the methods. That's all it means. So for a class to implement some interface just means that that interface specifies some set of methods, and this class provides all of those methods. By providing all of those methods, it's what's called implements the interface. Okay? And it's perfectly fine for a class to not only implement an interface, but also to extend some other class. That's perfectly fine. So the syntax is just going to get longer up here. But I just want you to see the implements syntax. And then inside here, just like you would be used to, actually, I'll just draw the opening brace here and inside here. This would be all of your code for the implementation of the methods would go in there. So it's the same kind of syntax for writing a regular class, but now you're just specifically telling the machine, hey, this class is going to support all this stuff from some particular other interface, like gfillable or whatever the case may be. Okay? So that's kind of the concept. Now, why do we sort of revisit this idea of interfaces? Is that now it's time to talk about some new things and the interfaces that they actually implement. So any questions about the basic notion of an interface or implementing an interface? Good call on the microphone.
How is this different from, does this work?
Sure, just press the button. We'll pretend it's working.
How is this different from extending a class or just calling an instance of of another class?
Right. So that's a good question. The difference between this and extending a class is, for example, the notion of a hierarchy that we talked about. So if we have some class that extends some other class, we basically say, right, like when we talked about, remember in the very first day, primates and all humans are primates? We would basically say any human is a primate. The difference is there might actually be some things that are not primates, and humans may actually implement a class like the G intelligence class, which means you have a brain that's larger than a pea or something like that. Turns out there's this other thing over here called a dolphin, which also implements the intelligence class, right? And we generally like to think of dolphins as a point of debate. I don't know how they actually measure this. There's like the dolphin SAT or something, the DSAT, and they're like, I don't know how they do it, but evidently someone has figured out how to measure intelligence in dolphins. So you could say this dolphin class actually implements the methods of being intelligent, right? Which might be some method like it responds to some stimulus in the world. But a dolphin's not a primate. So, at least as far as I know. Dolphin's not a primate, so there's no extends relationship here, and that's the difference, right? So an interface, in some sense, provides more generality. When you extend a class, you're saying there's a direct hierarchical relationship among those objects. Interfaces, you're just saying there's this thing like the intelligence interface. And sometimes these get drawn with dashed lines when you see them in diagrams. Both humans and dolphins provide all the methods of the intelligence interface, but only a human is a primate. That's the difference. Okay? So any other questions?
Is the code in this instance the code for that particular class or for the interface?
Pardon?
You wrote code there, as in, is that the code for that class or for the interface?
Yeah, so the code here is the code for class name. And somewhere else there would actually be the code for the interface. And that's covered in the book. We're not actually going to be writing an interface together, which is why I'm not showing that to you here in detail. But the basic idea is just so you would actually see that when a class implements an interface, what that syntax would look like.
Can you implement more than one interface?
Yes, you can implement multiple interfaces. So for example, grect implements both the gfillable interface and the gresizable interface, and that's perfectly fine. It's a good time. All right, so let me move on a little bit and talk about something that we're actually going to deal with, which is an interface, which is why we kind of revisit the subject. And the particular thing we're going to talk about is something that's known as a map. Okay? So a map, and you might look at this and you're like, map? Well, is that like, oh yeah, the travel guide? Like I got one of these and I kind of look in here and I'm like, yeah, where was I going? Like, oh, here's a map of all the interstates on the United States. And I'm sure this is copyright mapquest.com. There's this map, right? Is this what you're talking about? No, this is not at all to do with what I'm referring to here as map. So when you think of the word map, you need to let go of what your previous notion of what a map might have been is and think of the computer science notion of a map. So basically all a map is, it's an interface in Java, which means it's some collection of methods that will implement some functionality. What are the methods? What is an actual map? What does it do? Okay? The way to think about a map is there's two key terms you want to think about for a map. One is called the key, and one is called the value. And basically all a map is it's a way of associating a particular key with a particular value. You might say, whoa, Maron, that's kind of weird. Yeah, that's a very abstract idea. So let me give you an example of a map that you've probably used throughout the majority of your life, but no one told you up until now that it was a map. Something called a dictionary. Anyone ever used a dictionary? The number is getting smaller and smaller. You're like, no, I just let my word processor spell correct for me. A dictionary is a map. Its keys are the words that exist in the dictionary, and the values are the definitions of those words. So what a dictionary gives you is the ability to associate a particular key with a value. It associates words with their definitions. And the important idea to think about a map is, in a map, what you do is you add key-value pairs. So like in a dictionary, like the Oxford English Dictionary, right? Every year there's a little convention and they actually figure out some new words that are considered part of English. And they add them to the map that is the OED. Anyone have a copy of the OED? Yeah, a couple folks. It's a good time. Just get it. You get the little magnifying glass version that's got like 4 pages on one page. Hurts your eyes, but it's a good time. That's what it is. We're just adding key value pairs. Now what you do in a dictionary is when you look things up in a map, you don't look them up by the value, right? It would make no sense if I told you, oh, look up the word for me that has this as its definition. You'd kind of be like, yeah, Maron, that's just cruel and unusual. The way a map works is you look things up by their key. You have a particular word in mind in a dictionary, you go to the dictionary, you look up that word, and then you get its corresponding definition. Okay? So what we like to think of a map in this abstract way, it's an association. It's an association of a key to a value, where when we enter things, we enter both the key and the value together, and when we look things up by saying, get me the value associated with this key. Okay? So dictionary is a simple example of that. There's other examples. Your phone book is same thing. It's a map. The keys in the case of your phone book happen to be names that you want to look up. And the values in the case of your phone book happen to be phone numbers. But it's also a map. There's maps kind of all around you. Everywhere in life there's a whole bunch of maps. No one told you they were maps before. And if I told you up before this class started, yeah, a dictionary and a phone book are really the same thing, you might kind of look at me sort of weird and be like, no, Miron, one is like storing like names and numbers and the other one's storing words and definitions. But when you tell this to a computer scientist, they're like, yeah, they're both maps. Because now you know what a map is. All right, so any questions about the general idea of a map? As far as we're dealing with right now, you can think of a key having just one value. But that value is really some abstract notion, right? So you could actually think we have some word, like let's say we have a dictionary that has multiple definitions. Its key could be a word, its value could be an array of definitions, right? So really, in the philosophical sense, the value is one thing. That one thing happens to be an array that stores multiple values. Okay? So philosophically, it's one thing. In terms of the practicality of what you're storing, you might actually be storing multiple things. And maybe for assignment number 6, you might actually do something like that, but that's not important right now because you're still working on assignment number 5. All right? So, which is something you're like, quick, write that down. We'll talk about it again when we get to assignment number 6. All right? So, map is a particular interface. So that means we need to define some class that actually implements this interface, that provides some notions of these key value abstractions for us. And so in Java, we have something called a hash map. Okay? A hash map is an actual class. It is a class that implements the map interface, which means everything that is a hash map implements map. Okay? Map is not actually a class in itself. Hash map is a particular class. Map is just a set of methods that I think are actually useful to have. Okay? Now, where does it get its name? Why do we call it a hash map? What's this hashing thing all about? And in the book in excruciating detail, it talks about hashing and what hashing is and how to implement hashing and hash codes and all this other stuff. You don't need to know any of that for this class. Okay? All you need to know is how to use a hash map. You don't need to build a hash map. If you want to build a hash map at CS 106B a couple weeks from now, you will build a hash map. You will have the joy of seeing the underlying implementation of hash maps in C++ of all things. But for right now, you just don't need to worry about it. The reason why it's called a hash map is it uses a particular strategy to store these key value pairs called hashing. And that's all you need to know. And because it's called hashing, we call it a hash map. That's life in the city. Okay? But so this particular hash map is a template, right? Remember we talked about templates and we talked about how the array list was a template and you could have an array list of strings or you can have an array list of integers or whatever the case may be. A hash map is also a template, but the key here is there are 2 types involved. It's like 2 scoops of raisins. You have 2 types involved in the template for a hash map. You're going to have a type for your keys and you're going to have a type for your values. So what does that actually look like in terms of syntax? Let me create a hash map for you. So now that you know all about interfaces, we can erase this part. So let's create a hash map. The class is called hash map. Because it's a template, it has this funky angled bracket notation. But it's going to have 2 parameters for 2 types for this templatized class. The first type is what are you going to have for your keys. So let's say we want to implement a dictionary. A dictionary for its key type is going to have strings because it's going to be words. What type? The next type. So you have a comma in here and then you specify the next type, the type for your value. For a dictionary, again, if we assume a simple dictionary that just has a single definition rather than multiple definitions, which could be an array, we're also going to just have a string for the value type. So hash map, string, comma, string, or sometimes we refer to this as a map from strings to strings because it maps from keys to values, okay, is how we would actually specify this. We need to give it some name, so we might call this dict for dictionary. And then this is going to we're going to create one by saying new hash map. And this is where the syntax gets a little bit bulky, but you just have to stick with it. String, string, And we're calling a constructor, so again, we have the open paren, close paren. Okay, and that will create for you a hash map that maps from strings to strings. Now, we could also create a hash map for a phone book. So let's create a hash map for a phone book. In the case of a phone book, you might say, hey, names are still going to be strings, but phone numbers, well, phone numbers, if they're generally 7-digit phone numbers, let's just say it's 7-digit phone numbers. We won't worry about the 10-digit phone numbers right now. 7-digit phone numbers, I can store that in an integer. And so you might say, hey, I'm going to have a hash map of string to int. And at this point, you should stop, because your compiler will give you an error. What's the problem with this? Int is a primitive, right? All these templatized types require objects for their types. They require classes, which means we can't give it a primitive. We have to give it the wrapper class integer. Okay? So it's going to be a map from strings to integer, and we'll call this thing phone book. And this is just going to be, we'll give you the syntax in full excruciating detail, hash map from strings to integer, calling the constructor, and that's going to create a hash map from strings to integers for you. The first thing doesn't always have to be a string. It can be whatever you want, right? You can have a hash map from, integers to some other integer, where you want to map from integers to integers if you want to do that. Some people do. I don't know why. Sometimes you do. Now, the other interesting thing is, because a hash map actually implements this map interface, sometimes the way you actually see this written is you'll see it written without the hash in front. Okay? Just for the declaration. Here you still have to have the hash, and here you still have to have the hash. But just in terms of the type, sometimes it will be written map string to strings is a hash map of strings to strings. And you should look at that, and at first you get a little bit tweaked out, because you're like, but Meron, you told me a map wasn't a class. You told me it was an interface. Yeah, and a hash map implements that interface. So what I'm saying is I want to create a map. That map is I'm going to call a dictionary, and what's the actual thing that implements that dictionary? It's a hash map. Okay? Because the hash map implements the map interface, it will have all the methods that a map expects. So anytime I use this guy and I say, hey, it's a map, and I call any of the methods for a map, it's perfectly fine, because a hash map is guaranteed to have implemented those, because it implements the interface. So just so you see this in code, sometimes you'll actually see the hash out here. Sometimes you won't. Sometimes you feel like a nut. Sometimes you don't. You should see it both ways. It makes sense both ways. But you can't drop the hash here, right? Because a map is an abstract idea. You can't say, give me a new abstract idea. Okay? That's not going to work. You can say, give me a new hash map. That's the concrete thing. And what am I going to assign that concrete thing to? Well, this concrete thing implements the abstract idea, so it's perfectly fine to say, yeah, here's the concrete thing. Use it in the place of this abstract idea. Okay? Any questions about that? Kind of funky, but that's the way it is. So when we have these key value pairs, how do we actually add stuff to our hash map and pull stuff out of our hash map? Okay? So there's two methods. There's a method called put and a method called get. These are the two most commonly used methods of the hash map. And the way these things work is put. Let me write them more toward the middle of the board. Put, strangely enough, I know this is going to be difficult to see, but put actually puts something in your hash map. So the way put works is you give it a key and a value. The types of those things have to be the types corresponding to whatever object you've created. So if I want to have, for example, I want to put something in my dictionary, I'd send the put message to the dictionary hash map, and I'd say, hey, add this key value pair, and key and value better have type strings to match this thing. Or if I have some phone book, I could say put key value, where value better be an integer, okay, and key better be a string. Besides putting things, it's kind of fun if you can put a lot of things in a hash map, but it's not so much fun if you can't get them out. It's kind of like you had your phone book, and your phone book was kind of like your cell phone that you put all these numbers in, and then you try to get a number out, and it just said, no, I'm not going to give you any numbers, right? You would probably quickly stop putting numbers in. Some people wouldn't. I don't know why, but I've seen that happen. Well, you're like, you've seen people not be able to get numbers out of their cell phone? Yeah, like their cell phone's busted, and they just can't deal with that. But that's not important right now. What is important right now is you actually want to be able to get values out. So out of our dictionary, you might want to say, hey, Meron, I want to get some particular word. I want to get the definition for a word, really. This word is my key. So one way I could think about it is it's a word I'm looking up, but in the abstract notion, it's really a key. And so what this gives me back when I call get on the key is it goes over here and says, hey, dictionary, do you have some value associated with the particular key? So if this key exists in the hash map, what it gives you back, so it will return to you the corresponding value. If that key doesn't exist in the hash map, it gives you back null if key not found. Okay? So that's the way you can determine, is this thing actually exist in my hash map or not? If I try to do a get on it and it's not there, I'm going to get back a null. Okay? So any questions about that? Uh-huh.
If the value is an integer, will it still give you back null?
Yeah, because integer is a class, right? So you're going to get back objects of type objects of type integer, and if you happen to look up something that's not there, null is it's the empty object. That's why you can't do int, right? Because there is no null int. That's why you have to do integer. Good question. All right, so let's create a little hash map, add a couple values to it. So if let's say I had my phone book, I could say phone book dot put. It's always a dangerous thing to give out your phone number, but it's on the first handout, 723-6059. Call, that's a good time. All right, so that's just going to put this thing is an int, right? So in order for it to become an integer, what's going to happen is this is automatically going to get boxed up for you as an integer, and then that's what's going to get stored. So this auto boxing is what's happening to you, which makes it a little bit more seamless to use it with an int. But if you try to do this in an older version than Java 5.0, it would actually give you an error because it didn't do the boxing for you. Notice there's no dash in there, by the way, because then my phone number would be some negative number because it'd be 723 minus 6059, and that's bad times. All right, so then we could add someone else to the phone book. Put Jenny. Anyone know Jenny's phone number? 8675309. It's amazing how much longevity that song actually. Like I remember listening to that song when I was in high school. But it's such a catchy tune. All right, and if you have no idea what I'm talking about, look it up. It's on the web. Just query 8675309. You'll find it on Wikipedia. It's not important. It's really totally irrelevant, but it's just fun. All right, so once I have these entries in the phone book, I could say something like integer mnum, because that's what I want to be Maron's number, equals phone book dot get, and give it Maron. Okay. Important thing to remember is the keys are all case sensitive. So if I put in a lowercase m on Maron here, it would return null because it wouldn't be able to find me. So keys are always case sensitive in maps. Just an important thing to think about. Okay? So with that said, we can actually get a little bit more concrete with the hash map. I need a volunteer. Come on down. It's easy. You're up close. You're going to be a hash map. Here's your hash map. I've just created you. You exist. Rock on. All right. So I hope you don't plan on taking notes anytime soon because it might be difficult as the hash map. So what we're going to do is we're going to actually we're going to call these commands on the hash map so we can actually store these things in there and then see what other things we can do. So normally the things that gives bulk underneath the hood to a hash map is our friend, the ding-dong. So what we're going to have is certain things that we're going to enter in our hash map, which is basically a ding-dong sandwich. And on one side we're going to have the key, and on the other side we're going to have the value. So what I'm going to do is I'm going to write the keys in black and the values in red so we can keep track of them. That way we won't get them confused in our mind. So the first key I'm actually adding is I'm going to add myself, Maron. I guess I could have written this before, but I didn't. So I have my key, and that key has with it a value, and the value sticks with it. Okay? So 7236059. I shouldn't have put the dash in there, but I accidentally put the dash in there, and I say put. And this goes into the hash map. Okay? At this point, I have no notion of what's in my hash map or ordering or whatever. I just created something, I tossed it in the hash map. So then I say, all right, well, Jenny, she was always a good time. You've got to listen to the song, right? If you have no context for the song, you're like, that's not funny. 8675309. We put Jenny in the hash map. Okay? Now that we have these things in the hash map, there's an interesting thing that comes up, right? Which is, oh, when I had an array list, like I knew how many things are in my array list. I could refer to the first element. I could refer to the second element. What's the first element in my hash map? You're like, well, you put in meron first, but it's not guaranteed to necessarily be the first element. Okay? A map has no intrinsic ordering. It's all just kind of mushed in there. All right? So there are some things we might additionally want to do on the hash map to give us some notion of what's in the hash map and how big the hash map is. So here's a couple more methods. If you could just bear with me. I swear, it'll be over soon. The pain, the agony. No, it's a good time. All right. So a couple other methods I might have to ask you to just move over slightly is we can remove a key. So if I ask to remove a key, what I pass it is the key. So I might say something like phone book dot remove, and I give it some key. Now, if that key exists in the phone book, it removes it from the hash map, and it is now gone. So if I call remove on meron, oh, hash map, I need meron. So you look somewhere inside the hash map, and you say, oh, here's meron, remove. Phone number goes with it. That's just the way it is. The key and the value always stay together. Now, besides removing something, and if meron didn't exist, so I could actually say remove Bob. You look in there, there's no Bob. You don't need to do anything with the hash map. It's sort of the simple operation. There's no exception thrown, nothing like that. I asked to remove something, it's not in there. We just keep sticking with it. But what I can also ask is, oh, phone book, do you contain a key? And so there's a method contains key that I give it a key and it returns to me a Boolean. So I can ask you, oh, phone book, do you contains key Jenny?
True.
True. Good times. Phone book, do you contains key meron?
False.
False, because the key's been thrown out, right? We already removed that key. And last but not least, we can ask the phone book for its size. So this will return an int. Phone book, what's your size?
1.
Excellent. Thank you very much. And you're done, phone book. Thank you very much. Nice work. And for that, we'll just, you and everyone around you, you can just, it's an array list of ding-dongs. All right. So that's the way you want to think about it. It's this bag. You put stuff in the bag, you take stuff out of the bag. Whenever you put stuff in the bag, you put them in pairs. When you take stuff out of the bag, it's always pairs. Okay? And all the work that you're doing is always in terms of your key, but the value is associated with it. So when you want to remove stuff or check to see if it contains, you never look based on the value. You always look based on the key. That's just the way things are. Okay? Now, this whole notion of maps is part of a bigger framework. And so if we can get the computer for a second, I'll show you the bigger framework, just real briefly. Okay? There's this notion called the collections hierarchy, which is you're like, oh my God, it's big, it's huge. No, most of the stuff you don't need to worry about, right? There's some of the stuff you've already seen. An array list you've seen. An array list is something called an abstract list, which is just the abstract concept of a list. And that actually implements an interface called list, which implements an interface called a collection. Okay? So the array list, this thing you've been using this whole time, we didn't tell you until now, is actually something that we could refer to as a collection in the same way that we can refer to a hash map as a map. Now there's a few other things in here that we're just not going to deal with in this class, like a tree set. Or you might notice over here there's something called a hash set. Hash set and hash map, not the same thing. Okay, so you should just know that. You don't need to know what a hash set is. You just need to know that it's not a hash map, right? Because the words aren't the same. If they were the same, then it would be called a hash map. But there's this notion of an abstract set that they are subclasses of that implement some abstract notion of a set. And so there's this big kind of complicated hierarchy. But the important thing to remember is all of this stuff at the end of the day is a collection. So there might be some operations we might learn how to do on collections that applies to all of it, because all of these things at the end of the day implement the collections interface. There's the same kind of notion for hash maps. The hierarchy is just a little bit smaller, so it's easier to see. A hash map is this notion of an abstract map, which we talked about. It's kind of an abstract concept that has key value pairs, and what really defines that is an interface that's called a map. Okay? Now it turns out besides hash maps, there's another kind of map, interestingly enough, called a tree map. And a tree map also allows you to put things into it and get things out of it. The underlying implementation, it's just a different way underneath the hood of actually implementing a map. Okay? And that's the whole critical concept here. The critical concept is the abstraction that the idea of a map interface gives you. When you think about something that implements the map interface, all you need to worry about is what are the methods that are involved in a map. Underneath the hood, hash map may have some different methods than tree map for some specialized kind of things, but we don't care. As long as we just treat everything as a map, someone someday comes along and there's the hash map, the tree map, and then they create the super cool funky map. And you're like, wow, the super cool funky map is just way more efficient than all these other maps that existed because someone had this great idea about how to implement maps, like in 2027. Well, if you go back to your code and everything's written in terms of the map interface, and super funky cool map, was that super funky efficient map? Got to get the name right. Actually implements the map interface, none of your code changes, except in one line where when you create your map, rather than saying map string string hash map, you say map string string super funky cool map. And everywhere else in your code, when you refer to dictionary, you're just using the methods of the map interface and no other code changes. So that's the power of thinking of the notion of object-oriented programming and object-oriented design in these abstraction hierarchies, is the fact that as new implementations comes along, and they really do, right? It's not like computer science is a static thing. 10 years from now, there will be other implementations of these things which will be more efficient and better than what exists now. But if we relied on always thinking about hash map, then our code would be much more rigid than if we just think about this abstract concept of map. Okay? Is there any questions about that? All right. So think abstractly. That's kind of the bottom line from that whole little diatribe. So the one thing that we want to think about is when we have these things like maps and array lists, and I told you an array list is part of this collection, what do I actually get with these things? Like, what does a collection buy me other than the fact that I get to draw this complicated picture and be like, oh, look, this is a collection framework, okay? What it gives you that's interesting is a notion of what we call an iterator, okay? What is an iterator? An iterator is just an idea, basically. It's a way to list through a set of values. Okay? What does that mean? What that means is if I have some array list, and that array list contains like 10 different items in it. One way I could think about that array list is having some for loop that counts from 0 up to 9, and I get each one of the individual values. Another way I can think about that array list, because an array list is really a collection, is, hey, if all collections allow me to have an iterator, this iterator will allow me to very easily, and I'll show you the syntax, have a sequential process of going through all the values in my array list. And for an array list, it's not as exciting as some other things, because you're like, but I already have a way of going sequentially through my array list. So let's just compare and contrast them. Okay? The idea when you think about having a list of values, okay, and having an iterator is, first of all, let's create the array list, and I'll show you how to get an iterator from it. So let's say we had an array list of strings. Okay? And we'll call this names, because it's going to just store a bunch of names for us. And so we say new array list. It's an array list of string. We're calling a constructor, so we have the parens. Then what I say is, hey, array list, I want some way to be able to go through all your elements in a very easy way, in an abstract way, right? Because I don't want to have this grungy syntax of asking you for your size and having a for loop. That's something that's sort of very specific to an array list. What I really want to do is kind of have this generalization to say, hey, you contain some set of values, and I just want to go through each one of your values one by one. Okay? So the way I do that is I create an iterator. An iterator has a templatized type. Okay? Because if I have an array list of strings and I want to go through all the values one at a time, the values are all strings, which means I need to have an iterator that iterates over strings. So the types are generally the same. If I have an array list that I'm going to iterate over, its iterator is always going to be the same type as the type of the array list. And I'll just call this it. And it, which is oftentimes you'll see iterators just either called I or it, just for shorthand, is names dot, and now it's time for you to see a new method of the array list, iterator. So what this method does is it says, hey, array list, give me an iterator over your values. And what you get is something whose type is iterator of strings. Now, how do you actually use that? Here's how you use it. So what you're going to do is you're going to have a while loop. And the way an iterator works is you can basically ask the iterator two questions. You can say, hey, iterator, are there any values left in you? And if there are, give me the next value. So the way you ask to see if there's any values left in the iterator is you say, hey, it, do you have a next value? So has next. That returns to you a Boolean, if it has a next value or not. And then the way you get the next value, interestingly enough, is you just say, hey, iterator, give me the next value, which returns to you whatever type your iterator's templatized type is. Right? So if you have an array list of strings and you have an iterator over strings, when you call it.next, you will get a single string. So if our array list over here, let's just say names, contain the names Bob, Alice, and a C name, cow. Not very popular, maybe it'll come into vogue someday. Name your child. I was thinking, yeah, I should name my child Cow Sahami. That would be so wrong on so many levels. But that's not important right now, besides the fact that my wife would probably beat me to death. But what this really gives you, if it names is this array list, is when I create the iterator, you can think of the iterator sort of sitting at the first value. And I say, hey, do you have a next value? And it says, yeah, I do. It doesn't give it to you. It just says, yeah, I have a next value. Oh, give me your next value. So it gives you back Bob as a string. Bob still is part of your array list. It doesn't go away. But now your iterator sort of automatically moves itself to the next element. And so when you say, do you have a next element? Yeah. Give it to me. You get Alice. And it moves itself down. And then you ask for the third value, and you get cow. And after you get cow, you say, hey, iterator, do you have a next value? So after it's given you cow, it's sort of gone off the end, and it says, I don't have a next value. Okay? And that's why you always want to check if it has a next value before you ask for it, because if you ask for a next value when it doesn't have a next value, that's bad times. Okay? And if you really want to know what that does, just try it in your code, and you can find out. Okay? It's always good to try some of the error conditions yourself. But this is the simple idea. Notice there's no notion of asking the array list for its size or anything like that, or needing to know that the array list is actually ordered. Right? And the important thing there is because there are some lists like array lists which are ordered. We know that Bob is element 0, Alice is element 1, cow is element 2. But we just talked about our friend the hash map. And now you're probably thinking, yeah, Marin, why were you talking about all this array list stuff when you're talking about the hash map? Because the hash map didn't have any ordering over its keys. And so one of the things we can do is we can ask the hash map, hey, what I want is an iterator over your keys. Okay? So let's see an example of that. Okay? So in terms of thinking about the hash map, right, and we could have done the same thing with a for loop in the case of an array list. That wouldn't have been very exciting. But I would completely trust that, oh, you could probably do that, or maybe you already did for your hangman assignment. Okay? When we think about a hash map by itself is not a collection, so it doesn't provide you with an iterator directly, right? And the reason why it doesn't provide you with an iterator directly is because if you were to say, hey, hash map, give me an iterator, it would say, but I store key value pairs. I can't give you an iterator over key value pairs because an iterator is only defined by one type. But what I can give you is I can give you a set of my keys, and that set of keys is a collection, so you can ask it for an iterator. And so the way that works is if I have some hash map, like let's say I had my phone book hash map, I can say, oh, phone book dot, and the method is called keyset. Lowercase k, it's sometimes hard to draw lowercase k, uppercase s. So what that gives you back is a set of just the keys, right? So just the strings of the names in the phone book. And then you can ask that key set dot. So this would all be on one line. Hey, key set, you're a collection. Give me an iterator. So you would say iterator. And what you're going to get back is you're going to, from phone book, right? Phone book, you're going to say, what's your key set? You get a set of keys. What's the type for the keys of phone book? Not a rhetorical question. Strings. So if I say, hey, you're a string set, give me an iterator, what you get back is an iterator over string. So I can assign that over here by having iterator of strings, and I'll just call this I equals phonebook.keyset. I need to have these parens in here because I'm actually making a method call. This looks a little bit funky, but the way to think about it is phonebook.keyset is returning to you a object, which is a set of keys, and then to that object you're sending it the iterator message, which is what's giving you back this iterator of strings. Okay? So once I get back this key set from the hash map and get its iterator, this exact same code over here works on that same iterator. Right? So I could use this code on an iterator that was generated from an array list, or I could share exactly that same code from an iterator that comes from the keys of my phone book. So if I had my phone book that had Maron and Jenny in it, what I would get is an iterator that's going to iterate over Maron and Jenny. It has no notion of the actual values that are associated with those keys because the iterator is just over the set of keys, not the corresponding values. Okay? Any questions about that? The other thing that's funky, just to point one thing out, is in an array list is ordered. So I'm guaranteed to always get my set of keys in that, or from the iterator in the same order as they're stored in the array list. So I'll always get as the first key whatever's at index 0, the second key will be whatever's at index 1, and so forth. Hash map has no ordering, right? Even though I entered Maron first and then I entered Jenny second, there's actually no reason why Jenny couldn't show up as the first value. The only thing I'm guaranteed that is that every value will show up once, but I get no guarantee over the ordering. So no order, and this one you always get order. Just something to keep in mind. Okay? Was there a question? Or was that the question? Yeah, just for thinking of it one step ahead of me. All right. So one other piece of syntax that's a little bit interesting to see that you should also see. Okay, so any questions about the notion of a key set or an iterator? If you're feeling okay with iterators, nod your head. If you're not feeling okay with iterators, shake your head. All right, question back there?
Does key set return an array or an array list? Like what does key set return?
It actually returns a set. And as far as you need to worry about for this class, you don't need to worry about a set. So the only time you'll actually use the key set syntax is with an iterator to get its iterator. But it actually is returning an object that is a set, or that it actually implements the set interface. Okay? Alrighty. So one last thing to see, and then I'll show you all of this kind of stuck together in some code, is Java actually gives you, because iterators have become such a common thing to do. Like people were writing this code left and right. They were writing this code till the cows come home, and they were like, oh, but it's such a pain. I got to create the iterator, and then I go through all the values. And that's such a common thing to do that I want to go through all the values. Wouldn't it be nice if there was some simpler way of doing this? And enough people sort of yelled and screamed this over the years that the people who created Java 5.0 said, okay, we're actually going to give you a version of the for loop, which is totally different than what you've seen so far. So now you're old enough to see the new improved for loop. And the way this new improved for loop looks like is you say for, you specify the type of the thing that you're going to get as every element of the loop. So in this case, you would say something like string name. Then you give a colon, and then you specify over here the collection over which you would like an iterator. What does that mean? That means the collection that you would like an iterator over is whatever thing you were calling the iterator method on. You do not actually call the iterator method, you just specify the thing that you would have called the iterator method on. So over here what we would actually have is phonebook.keyset. Phonebook dot, this would all be on the same line, keyset. Okay? And then inside this loop, what you can do is this word, this name of this variable, is a declaration of a variable that sequentially will go through all of the elements of this collection over here. And so this collection could be the key set from a phone book. It could actually be an array list, because over here we were asking the array list directly for an iterator. So we could say, hey, for every string name, colon names. And that means give me the name one at a time out of names. And inside here we could do something like println name. So name is just a variable. The way you can think of name is getting the value one at a time of an iterator over whatever you specified here. But the funky thing about this is you never created the iterator. You never said, hey, I need an iterator. You just said, yeah, this thing, you can get an iterator from that. And I want to get things one at a time from this iterator. And the name I'm going to specify for that thing that I'm getting one at a time is this variable over here. And it's going to have this type. And so this syntax, Java automatically, what it will do is construct for you basically underneath the hood. You never need to worry about the syntax except for that. It will create an iterator for you. It will automatically check to see if the iterator has a next value. If it does, it will assign that next value to name and then execute the body of your loop. And after it executes the body of your loop, it comes back up here, checks to see if iterator has a next value. If it doesn't, then it immediately leaves the loop. If it does, it gets the next value, sticks it into this variable, so it clobbers the old value, but it sticks it into this variable, and then you can do whatever you want. So this will actually write out the whole list of keys from the phone book. Okay? And this only exists in Java 5.0 or later. And sometimes people refer to this as the for each construct. Okay? But the name's not as important as just understanding the syntax. And if you try to do it with something from Java in an earlier version than 5.0, it just doesn't work. Okay? So any questions about that? So let me show you some code that kind of puts this all together. a little code. Okay, so here's a little hash map example. What I'm going to do, and I put in a little bit of printlns here just so you could see, like, remember we talked about our little lecture on debugging, right, where we said, hey, you know what, before you call a function, just add a println. You know you got to that function. That's all you need to do, right? Then you know before you're going to call this function, hey, I'm about to call that function. It's the simplest form of debugging if you didn't have sort of the full power of Eclipse, you know, available to you. All right. So what we're going to do is we're going to read in phone numbers by reading in a list of phone numbers. What are we going to read them into, right? Because we're not passing a parameter here. We must have some instance variable. So down here I have an instance variable that is, ooh, and I forgot private in front of it. My bad. So it's a private instance variable. It's a map from strings to integers, because this is our friend the phone book that we just talked about. And what I'm going to create for this map, notice I'm just saying map here, the actual implementation I'm going to use is a hash map from strings to integers. Okay? So it's the syntax you saw before I erased it. And then what we're going to do is to read in the phone numbers is we're just going to ask the user, give me a name. So we're going to have a while true loop. Give me a name. We read in that name. If the name is equal to empty string, then I know the user is done entering names. And if they gave me a valid name, then I say, hey, give me a phone number as an integer. So I get the phone number as an integer, and then I will add that name-number pair to the phone book. Notice, because this is an int, there's boxing going on here. This number is automatically getting boxed up for you to go from being an int to an integer, so I can stick in a string and an integer into the phone book. Again, that only works in Java 5.0 or later, but that's what you should be using. So after I read in all these numbers from the user, I'm going to allow you to look up numbers. And the way I'm going to look up numbers is I'm going to say, I'm going to keep looking up numbers until you tell me you're done. So I'm going to ask for a name to look up. If you're done, you'll give me a name that equals the empty string to indicate that you're done looking for names. Otherwise, what I'll do is I'm going to ask the phone book to get that name. Okay? What it's going to give me is it's going to go look up the name. It's going to go look up Jenny in the phone book and say, hey, Jenny, are you there? And if Jenny's there, what I get back is the value associated with Jenny, 8675309, as this integer, right? I don't get back an int. I get back an integer. And this is critical. I shouldn't declare this as an int here. And the reason I shouldn't declare this as an int is because there's a chance that number could come back null, right? So if I say, hey, phone book, give me the number for Bob, and it's like, there's no Bob in the phone book. Sorry, here is null. I can't treat that null like an integer. I can't box and unbox the null. So I need to specifically check for that, and then I'll say that name is not in the phone book. Otherwise, what I'll do is I'll print it out, and when I print it out, then it does the unboxing for me and prints out the integer. Okay? So that's lookup number. Last but not least, I want to display all the phone numbers at the end that are in the book. So what I'm going to do, I can actually show you two versions of that. One version uses our happy friend, the iterator. It says, oh, phone book, give me your key set, and from the key set, give me an iterator, and I will assign that to it, which is an iterator of type string. And then I'm going to do the loop that you just saw before. While the iterator has a next value, I'm going to get its next value, which is a name, right? All the iterator is just iterating over all the keys, which are names in the phone book. To get the associated number, I need to say, phone book, get the number associated with that name, and then I print it out. Note here, I don't check for an error condition, because I know all of the names that I have are valid names in the phone book, because I got them from the phone book. So I know when I go look them up, they'll always be there. And the alternative way I could have done this is using this for each syntax, which is, oh, just so lovely, right? I don't create an iterator. I just say, for every name that's in my phone book key set, get me the number by looking up that name in the phone book. And then I just print it out. Okay? So just so you believe that this actually works, and then we'll go in our final minute together. So we put in Maron, 723-6059. I won't give you my home number, ever. No, just kidding. I did 1/4. That was a mistake. Jenny, 8675309. I won't ask you to give me a number, because it will be down in TV and like random people will call you and be like, is this your real number? Because it turned out when that song came out about Jenny, a lot of people called that number, and there were people who got really angry because some people really have that number. So we're done entering numbers. So we're done entering names, and we want to look up someone. I want to look up Maron. Maron's not in the phone book. Case sensitive. I need capital Maron. So Maron is in the phone book. I'm done looking folks up. And then it displays the phone numbers. Notice it displays Jenny first, even though I entered Jenny second, because a hash map has no guarantee of ordering over the iterator. Okay? Important thing to remember. So any questions about anything you've seen? Alrighty, then I will see you on Friday.